All right, this is the quiz from Friday, January 20th. I'm going to go over the solutions to this quiz. Question 1a is asking us to graph this arctangent function. So let's go ahead and graph the parent function, arctangent of x. The outputs of arctangent of x have to be in the interval from negative pi over 2 to positive pi over 2. And there's a horizontal asymptote at y equals pi over 2 and y equals negative pi over 2. The arctangent of x has a y-intercept at 0. This is what our curve will look like. Now, the problem you're being asked to graph is a shift of the graph I just drew, arctangent of x, to the left 1 unit. So I want to take that function there. We're shifting it to the left 1 unit. If I'm shifting the horizontal asymptotes to the left, they're going to stay at pi over 2 and negative pi over 2. Only if I shift the graph of arctangent up or down would those change. And now here's my curve. So that x-intercept is negative 1. But I want to find this y-intercept. So I'm going to figure out what the arctangent of 1 is. To find the y-intercept, we need to plug in 0 for x. We get y equals arctangent of 1. So when I see arctangent, I'm thinking about the output will be an angle for sure, but tangent, I'm thinking slope. And the slope of the angle is going to be 1. So the outputs of arctangent have to be between negative pi over 2 and pi over 2. So this answer here, this y-intercept, will be pi over 4. All right, 2b. I can see that the coefficient of cosine, it's a 1. The amplitude is 1. So the max value will be 1 and the minimum will be negative 1. Now, I know there's a shift. It's actually left. We're shifting y equals cosine of 2x to the left, actually pi over 4. Not pi over 2, but pi over 4. My preference is not to even think about the shift at all. My hope is that the y-intercept is at the max, the min, or at the origin. So I'm going to find the y-intercept by plugging in 0 for x. And we get the cosine of pi over 2. The cosine of pi over 2 is 0. So the x-intercept's at 0. This is great. If it was going to be a value in between 0 and 1 or between negative 1 and 0, I'd have to go ahead and graph this using transformations. But I'm not sure if the graph is increasing initially or decreasing, so I'll figure that out in a moment. But I know that the next x-intercept is half a period apart from the previous one. The x-intercepts are half a period apart. So the period of this function is 2 pi divided by the coefficient of x. So I'm going to divide by that 2 there, and that's pi. So the x-intercepts are half a period apart. So half a period will be pi over 2. So this first x-intercept to the right of the one at the origin is pi over 2. If I add pi over 2 again, I get pi. And therefore we know these intercepts. Now, I'm not sure if the graph is above or below the axis initially as we go to the right. I don't know if it's above there or below. But one thing I do know is that in between 0 and pi over 2 is pi over 4. And so I want to plug in pi over 4, and if the output's positive 1, then I know the graph's above the x-axis there, or if it's negative 1, it's below. So I'm going to plug in pi over 4 for x and figure out what the output is. So I'm going to let x equal pi over 4. We get y equals cosine 2 times pi over 4 plus pi over 2. This will become cosine of pi over 2 plus pi over 2, which becomes pi. And if we evaluate that, that's negative 1. So now I know at pi over 4, the output is negative 1. Therefore, the curve is down beneath the x-axis where I'm drawing it right now, and then it goes above. You could graph this by transforming the function y equals cosine of 2x to the left pi over 4 units, but that's not my preference. Part C. When you see y equals negative 2 sine of x, you should realize that the amplitude is going to be 2. It's going to go up to 2 and down to negative 2. But we also have that vertical reflection. Now, besides those transformations, we're also shifting the graph up 1 unit. So we see 1 minus 2 sine of x. So that 1, we're shifting the graph up 1. So now the max value will be 3, and the minimum will be negative 1. Now, if you plug in 0 for x, you get sine of 0 is 0, times 2 is 0, so 1 minus 0 is 1. So the y-intercept's at 1. You could also look at the parent function I have, the negative 2 sine of x. That's going to be shifted up 1 unit. And now I'm going to sketch my curve. All right, so I'm going to make this x-intercept blue, this one pink right here. I'm going to go ahead and find my x-intercepts by plugging in 0 for y. I solve this equation, I'll get sine of x equals 1/2. Here's our unit circle. When I see sine of x, I'm thinking sine. I'm looking for y coordinates on the unit circle of a half. That'd be right here is one of them. And here's the other point. So in the first quadrant, if I go counterclockwise, that first angle is pi over 6. In the second quadrant, I have 5 pi over 6. Now, if I go clockwise from 0 around clockwise, I'm going to hit that pink angle first. Whoops, and I can see I didn't do a great job here. The curve needs to go beneath the x-axis, hit the minimum, and come back up. All right. So this intercept here in pink is going to be negative 7 pi over 6. And then if I go all the way around clockwise, that one in blue is negative 11 pi over 6. The blue x-intercepts are 2 pi apart, and so are the pink ones. The pink ones are 2 pi apart from each other. Part D. So we want to take the parent function arc cosine of x and shift it down 2 pi over 3. So you have to know the outputs of arc cosine are 0 to pi. The range of cosine is negative 1 to 1. Therefore, the domain of arc cosine will be negative 1 to 1. Now, cosine of 0 is 1. So the cosine function has a point at 0, 1, but the inverse will have a point at 1, 0. And then we know that cosine of x has an x-intercept at pi over 2, but that becomes our y-intercept for the inverse function. This is what the parent graph looks like. So the problem we're trying to graph in part D, we're shifting that graph down 2 pi over 3. So that means our minimum value now will be negative 2 pi over 3. Our max was pi, but now it'll be pi over 3. The y-intercept of arc cosine is pi over 2. But now we have to take away, we have to shift every point down 2 pi over 3. So if we create a common denominator here, (3 pi over 6 minus 4 pi over 6 will give us negative pi over 6. The domain will stay negative 1 to 1 because we're shifting the graph down, not left or right. And so I'm going to match the shape of the curve as before. I want you to label the endpoints. So I want you to label this point on the fourth quadrant 1, comma, negative 2 pi over 3. This point in the second quadrant is negative 1, comma, pi over 3. Now I notice that there's this x-intercept here. So I want to find that x-intercept. So I'm going to plug in 0 for y. Add 2 pi over 3 to both sides. Take the cosine of both sides to undo the arc cosine. Here's the angle 2 pi over 3. The cosine of that angle is negative 1/2. Part E. We want to graph arc sine of x, but we're going to shift that graph to the right, rad 2 over 2. So we have to first know what the parent graph looks like. The range of arc sine of x is like the range of arc tangent of x. It's negative pi over 2 to pi over 2. The range of sine, the sine function, sine of x, goes up to 1 down to negative 1, so that range becomes the domain of the inverse sine function. Sine has a point at the origin, 0, 0. That's going to stay there for the inverse. But then the point for sine of pi over 2 is 1. Pi over 2 comma 1 becomes 1 comma pi over 2, so there's a point here and a point down here. Now the concavity looks like the same concavity as y equals x cubed. So this point here is 1 comma pi over 2, and this is negative 1 comma negative pi over 2. That's our inverse sine function, the parent graph. Now for part E, we're shifting that function to the right, rad 2 over 2. That's not going to change our range. The max value will still be pi over 2, and the minimum will be negative pi over 2. Only if we shift it up or down would it change that range. So that blue point where I have the x-intercept is going to go over here to rad 2 over 2. I'm going to sketch my curve. Now, the far right side of that endpoint in the first quadrant, it was 1 plus we're shifting it to the right, rad 2 over 2. and the y value is still going to be pi over 2. The point in the third quadrant, the x coordinate was -1, but then we shifted it to the right, rad 2 over 2. Now I want to find this y-intercept. So I'm going to plug in 0 for x. And I get arc sine of negative rad 2 over 2. So it's going to be, the output has to be in between negative pi over 2 and positive pi over 2. So it'll be that angle in the fourth quadrant, but specifically negative pi over 4. And that's our graph. All right, 1f. So I'm going to graph 2 cosine of x. That range is -2 to 2. Cosine has a point on the y-axis at its relative max. This is our curve here. Now we have to shift that graph to graph the equation in 1f. We have to shift this graph up square root of 3. So our max is 2 plus square root of 3. Our minimum is -2 plus square root of 3. So we're shifting the whole graph up square root of 3 units. Now, we're still going to have a point on the y-axis at its relative max. If you plug in 0 for x, you get cosine of 0 is 1, times 2 is 2, plus rad 3. I'm going to sketch my curve. Okay, this graph is symmetric to the y-axis. All right, now we're going to find these intercepts. All right, the x-intercepts. We're going to plug in 0 for y. Subtract rad 3 to both sides. Divide both sides by 2, and we get cosine of x equals negative rad 3 over 2. So, starting at 0, if we make our way counterclockwise, that first angle there from 0 will be 5 pi over 6. Starting from 0, going counterclockwise, that angle there in the third quadrant will be 7 pi over 6. Starting at 0 and going clockwise, that angle in orange here will be negative 5 pi over 6. And going clockwise from 0, we get to negative 7 pi over 6. And these intercepts should be symmetric to the y-axis. The orange intercepts are 2 pi apart, and so are the pink ones. Question 2. We want to evaluate sine of 2x. We're given cosine of x equals 1/3, and tangent of x is less than 0. See, when it says cosine of x outputs a positive, that means the angle x could be in the first or fourth quadrant. But because the directions clarify that tangent of x is negative, that means x cannot be in the first quadrant. It has to be in the fourth quadrant. So I'm going to label this angle here x. The cosine of x is the adjacent side divided by the hypotenuse. If you use the Pythagorean theorem to find the missing side, this will be 2 rad 2. But because we're going from the origin to the right and then down, because we're going down, I'm going to label this negative 2 rad 2. So sine of 2x, I'm going to expand that using the double angle formula. So this equals 2 times, using that triangle, the sine of x is negative 2 rad 2 over 3. And the cosine of x is 1/3. Simplify this, I get negative 4 times rad 2 over 9. Cosine of 2x. Now, you might want to use cosine squared x minus sine squared x, which is fine, and plug the values in there. But some students made a mistake when drawing the triangle, or they made a mistake when squaring the sine. So I would actually prefer to use the formula 2 times cosine squared x minus 1, because the directions give us cosine of x. And so if I find sine of x incorrectly, I'd get the answer wrong. But now I'm just going to use the value they gave us. Feel free to use either one, whichever formula of those two you want. So I'm going to square 1/3. That becomes 1/9. I'm going to create a common denominator because I can see the future there. So I made this minus 1 minus 9 over 9. This is going to be 2/9 minus 9/9 equals negative 7/9. All right, solve on the interval from 0 to 2 pi. So sine of x equals negative 0.2. Now, there's 2 points in each circle that have a y value of negative 2. There's one right here, and there's one right there. Now, I'm not familiar with this angle, with these angles, meaning they're not a multiple of pi over 4 or pi over 6. But if I take the arc sine of both sides of this equation, I get the arc sine of negative 0.2. Now, that would actually be the angle in the fourth quadrant. But it would have to be in between negative pi over 2 and 0. See, it's right here. From 0, we're going clockwise. That angle is a negative value because you know the outputs of arc sine have to be between negative pi over 2 and positive pi over 2. So that means in order to put this angle in between 0 and 2 pi, I have to go all the way around. I have to add 2 pi to it. All right. Now, I can see between 0 and 2 pi, you have the pink angle and the blue angle. There's two solutions. So right now I just wrote down one solution. It's just the blue one. So what some students do is they write arc sine of positive 0.2. I'm going to make it dotted. That would be right here where it's dotted. But I need to get to where the solid pink angle is. And so I have to add pi to go all the way around. So instead of this one I just circled, some students do negative arc sine of negative 0.2. That would still give you that dotted angle in the first quadrant, and then you have to add pi. So it's your choice between either one I circled or the other one in pink. All right, part B. So this is tangent, and we recognize this value negative square root of 3, it is the slope of the angles like 2 pi over 3 and 5 pi over 3. So I'm going to go ahead and draw that slope of negative rad 3. Okay, so between 0 and 2 pi, I see two angles. So I think there's two solutions between 0 and 2 pi. There would be, but see, it says tangent of 2x. So I know I'm going to have double the amount that I thought originally. I'm going to actually have 4 solutions. So I'm going to write down 2x. I'm getting that from tangent of 2x is equal to that angle in the second quadrant. I'm going to call that 2 pi over 3. And to go from that angle in the second quadrant to the angle in the fourth quadrant, back to the angle in the second quadrant, you keep adding multiples of pi. So I'm creating an equation that represents all of those angles in pink and blue, where k is an element of the set of integers. Now I'm going to divide both sides by 2, or multiply by a half, and we get this here. Now the directions say they only want solutions between 0 and 2 pi. So one of our solutions is pi over 3. But now if we let k equal 1 and you add pi over 2 to that, I'm just going to create a common denominator real quick. So pi over 3 is the same thing as 2 pi over 6. Pi over 2 is the same thing as 3 pi over 6 times k. So if k is 1, I'm going to get 2 pi over 6 plus 3 pi over 6 is 5 pi over 6. Add 3 pi over 6 again, I get 8 pi over 6, which reduces to 4 pi over 3. So 8 pi over 6 plus 3 pi over 6 is 11 pi over 6. And 11 pi over 6 is so close to 2 pi, so if I add pi over 2 again, I'm going to be out of bounds. I'm going to be out bigger than 2 pi. So these are our 4 solutions. All right. Part C. I'm going to add 5 to both sides of the equation. So I get 4 on the right side. I'm going to divide by 2. Now you can multiply both sides by cosine, or you could just take the reciprocal of secant of x is cosine of x equals the reciprocal of 2 is a half. And we're trying to find the solutions between 0 and 2 pi. It's the same for all these parts here. So x equals a half. It's going to be right here. These points on the unit circle have an x coordinate of a half. So x will equal, the angle in the first quadrant is pi over 3. And the angle in the fourth quadrant is 5 pi over 3. Part D. I see the sine function here. And I do know of the coordinate on the unit circle where the y coordinate is negative 1. So when I see sine of an angle, I'm thinking the y coordinate on the unit circle, that's going to be negative 1, which is right here in pink. So between 0 and 2 pi, I'm only seeing one solution. But again, we have a 2x here. So my hypothesis is there's going to be 2 answers to this problem. So I write 2x minus pi over 3 equals. So it's like I took arc sine of both sides in a sense, but I have to list every answer possible right now. So that's 3 pi over 2 plus 2 pi k, where k is an element of the set of integers. Now I'm going to add pi over 3 to both sides. And so I have to add these two angles, and they don't have a common denominator, so I'm going to multiply this by 3 over 3, multiply pi over 3 by 2 over 2. So I get 2x equals, that pink 3 pi over 2 is equivalent to 9 pi over 6, plus 2 pi over 6, that's 11 pi over 6. When I add up that pink and blue number, I get 11 pi over 6 plus 2 pi k. Now I'm going to divide both sides by 2, or you can multiply by half. It's the same thing. Now, if I wanted every single answer and the directions just said solve, that'd be my solution. But the directions for all these problems want answers between 0 and 2 pi. So when k is 0, we get 11 pi over 12. When k is 1, here's what I'm thinking. 12 twelfths pi is the same thing as 1 pi. So when k is 1, I have to add 11 pi over 12 plus 12 twelfths pi is 23 pi over 12. That's just shy of 2 pi. It's not quite 2 pi, which is great because we need answers between 0 and 2 pi. All right. So this problem here, cosine of x equals negative 0.7. I'm not familiar with an angle that crosses the unit circle at an x coordinate of negative 0.7, meaning x, the angle x, isn't going to be a multiple of pi over 6 or pi over 4. So I'm going to draw in the unit circle where I would think x equals negative 0.7 is. I'm going to draw the angles going through those points. Now, if I want to solve for x, I'm not familiar with this value, I'm actually going to take the arc cosine of both sides. I get the arc cosine of negative 0.7. Now, let's go back at our parent graph of arc cosine of x. Let's look at it. It's right here. See how the outputs of arc cosine of x are 0 to pi? Arc cosine of x cannot output a negative. So I know for sure that this angle in pink is between 0 and pi, because arc cosine has to output an angle between 0 and pi. So that is one of our solutions. Now, that's the angle in pink. The angle in blue. Some students take the one in pink and they multiply by -1, which if you're looking at my circle I drew, that's going to be going counterclockwise. No, it's going to be going clockwise now because it's going to be a negative angle. And so it does end up at the location, the terminal side of that blue angle. It ends up there. But the problem is it's out of bounds right now. It's not between the 0 and 2 pi. So I have to go all the way back around. I have to add 2 pi to put it in bounds. What some students do is instead of the answer I just circled, they know that right here in the first quadrant, this is arc cosine of 0.7, where the x value, the x coordinate where that angle intersects is 0.7. And then they'll add pi. So instead of this answer that I circled, instead, students will do arc cosine of 0.7 plus pi to end up where that blue angle is in between 0 and 2 pi. It's your choice. Okay, so there's only 2 answers to this problem, but you have a couple options on how to write that second answer. Alrighty. F, we could probably squeeze it in there. Let's go ahead and subtract 1 to both sides. divide by 4. Take the square root of both sides. You need plus or minus. The square root of 1 is 1. The square root of 4 is 2. Cosine is talking about the x coordinates on the unit circle. So cosine of these angles, the x coordinates are a half, but also negative a half. X equals pi over 3 is the angle in blue. 2 pi over 3 is the angle in orange. 4 pi over 3 is the one in purple. And 5 pi over 3 is the angle in pink. All right, question 4. So let's first evaluate the sine of 7 pi over 6. Here's the angle 7 pi over 6. The sine of that angle is negative a half. Now the arc sine of negative a half, if you go back to the parent function of arc sine, it has to output an angle in between the ranges negative pi over 2 to pi over 2. So our answer has to be in between negative pi over 2 and pi over 2. So some people, well, let's just emphasize this negative a half here for y is there in blue. And there's another point I just drew in the fourth quadrant where the y value is negative a half. So if students had a wrong answer, the popular wrong answer for this one was saying that this outputs 11 pi over 6, so that's impossible. Arc sine cannot output a value past pi over 2. Or if I'm going clockwise, it can't go past negative pi over 2. So 11 pi over 6 is out of bounds. The correct answer is negative pi over 6. Part B. Cosine of this angle, cosine of pi over 12, sine of the same angle as the first one, and sine of pi over 12. You need to recognize that this is the it's the angle addition formula. The angle addition formula for cosine. Except I'm expecting to see a minus here in between the two groups of terms. Since that's not a minus sign, I'm not going to put a plus in between these two angles. It has to be a minus. So the angle addition formula for cosine, if this is going to be a plus in the middle, then that would have to be a minus sign between these groups of terms. So it's a minus here. And it's 5 pi over 12 minus pi over 12. It doesn't matter if you rearrange those values for this problem because cosine's an even function, so you'll get the right answer either way. This reduces to 4 pi, or it simplifies to 4 pi over 12, and that simplifies to pi over 3. So here's the angle pi over 3. The cosine of that angle will be 1/2. Part C. All right, I'm going to let arctangent be some angle theta. Now, because that's arctangent, it has to output an angle in between negative pi over 2 and pi over 2. But I know it's the first quadrant. It's between 0 and pi over 2 because the output is, because it's arctangent of positive 3/4. If you remember SOHCAHTOA, so basically what I have here is I have tangent of theta equals 3/4. Tangent of the angle equals the opposite over the adjacent. Using Pythagorean theorem or your knowledge of 3, 4, 5 right triangles, that hypotenuse is 5. This problem is saying cosecant. I know the sine of theta is the reciprocal of cosecant. The sine of theta is given a right triangle, is the opposite side of the angle divided by the hypotenuse. That means cosecant of this angle is the reciprocal of that. Okay, question 5. I'm going to condense this by using our properties of logarithms, the product property. And this becomes x squared minus 4x. Now I'm going to undo the logarithm, the natural log, by taking the inverse of both sides, which is base e. So the left side will be x squared minus 4x, and the right side is e to the 1. So it's your choice now. You could subtract e to both sides and use the quadratic formula, or you can complete the square. Some people just thought that we're going to add 1 to both sides because that's what we did last week. But if you want to complete the square, this should be x minus 2 squared, or x minus 2 times x minus 2. I think people knew that. It's going to be, this negative 4x here, negative 2 and negative 2. But when you multiply negative 2 times negative 2, that's actually positive 4. We need to add positive 4 to both sides in order to get those two factors I have below, which is x minus 2 times x minus 2. So no, it's not going to always be adding 1. What you do is this blue number I highlighted, you take half of that blue number. It's negative 4. You take half of it and square it. That's the formula to find out. That's the pattern you'll see with completing the square. So half of negative 4 is negative 2. You square that, and that's how you can get that pink 4, besides how I showed you down here by writing the factors. So the x squared minus 4x plus 4 will factor to x minus 2 times x minus 2, which can be written as x minus 2 squared. Now we'll undo that square by taking the square root of both sides. Don't try to simplify this. The square root of e plus 4 does not simplify. You can't distribute that square root to terms. I'm going to add 2 to both sides. Now, this is almost our solution. There's 2 numbers here. I have 2 plus the square root of e plus 4 and 2 minus the square root of e plus 4. And those would both be solutions to the second step there. But before I condensed, I had natural log of x alone here and natural log of x minus 4. So x cannot be, it technically has to be a number bigger than 4. X can't be negative because you have a natural log of negative. And in my solution,